All right. I hope everybody's having fun. It's early day still. Got a lot to talk about. So this is my session. So I don't have slides in front of me, so I have to keep looking up like everybody else. So breaking the ice. I'm really going to talk about kind of data unification and what does that mean. I think some of you folks probably seen on social media and maybe in the public news a lot of the conversation around Apache Iceberg. Snowflake had their earning announcement a couple days ago. Lots and lots of talks about it. So you'll hear more about that. All right, so who am I? Here's my picture. You don't really need a picture up there. Hopefully you can read this. So Roy Hasson, I'm a VP of product at a company called Upsolver. Been with the company for about 2 years. Previously, I was with AWS, leading some of the analytics products there. Before that, lots of history, not related to data at all. So like 15 years in networking and actually moving data around, but not physical data. So this has been my last few years. So this is me. I didn't actually go skiing. I really wanted to, but I didn't bring gear, and I didn't want to go skiing, so instead I went hiking. It was awesome. It was a lot of fun. So if you get a chance, go for the hike. It really wasn't that long. It took, I don't know, a couple hours up and down. It was a blast. It was a beautiful day yesterday. I even had my T-shirt up. God, I don't know what it was, like 1,800 meters. Cool. So there's a lot of kind of funny slides in the beginning. So I tried. I'm not very good at prompt engineering, as everybody knows. So this is my attempt at creating these AI pictures. But anyway, the point here is that innovation is hard. We all here try to innovate for our companies, whether you're a company trying to build data products, or you're a company like myself trying to build products for people who want to build data products. Innovation is hard. We see a lot of technology out there that kind of looks innovative, but in reality, it really isn't. It's kind of like repackaging. So there's a little bit of a dig towards the modern data stack, and I'll talk a little bit about that as well. But a lot of what we see these days is kind of repackaging old ideas and old technologies in shiny new ways. And when you have some new startups coming in, some new folks coming into the data space, they look at these things and say, oh my God, this is the best thing, like ETL or ELT. Nobody has ever heard about it. I'm going to create a product around it. It's going to be amazing. But in reality, they're just packaging stuff that we've done before. So modern data stack, we talked a lot about that. In the early 2000s, maybe late 90s, that was the modern data stack. Probably more tools than that. I'm just making it simple. 2010s, that was our modern data stack. Nowadays, we have this, right? But in reality, it's not modern. It's really all about packaging. How do I make it easy for users to buy a solution as opposed to buy a bunch of piece products? So if I go to a hardware store, I want to buy a whole bunch of things to go build my house. But in reality, I just want to go to a builder and say, I just want a house, right? Bring all the pieces and everything is good. So that's really all it is when we talk about modern data stack. There's really nothing special here. They're solving the same problem that we've been trying to solve for years, just with today's modern technology. But the reality of the whole thing, whether it's modern data stack, not modern, whichever tool you end up using, data volume, complexity, and the number of use cases that our business is trying to consume and deal with is continuously increasing. If you look at generative AI, LLMs, all that fun stuff around AI, it drives a tremendous amount of data. If you don't have that kind of data, you're not going to be able to build models that are realistic and that are helpful. Right? So data is at the heart of a lot of these conversations. So when we talk about AI, we tend to forget the massive amounts of data that we have to consume, process, improve, and then feed into these models. It's always fun to talk about the shiny things, not about the things under the hood that actually drive the shiny things. So again, we're still siloed. So when we're talking about whether you're on the left side, you're a data warehouse person, you're building a stack, you're enjoying analytics, you're building BI dashboards, or you're that person in the middle where you really want to get into AI, but you're not quite there yet. You don't really know what to do, so you go with a packaged solution. You go to OpenAI, you go to AWS with SageMaker. You kind of look at a packaged way of doing AI, or you're all the way on the right side where you're just a master. You're out there, you're like Evo over there. Sorry for picking on you. Building your own models, training your own data, doing everything on your own, running your own Kubernetes clusters. At the end of the day, we're doing analytics and we're doing AI. There's a lot of different ways to do it, but we're creating these silos. We try to run away from silos in the enterprise, but ultimately we're creating more silos just because of these technologies and the way that we handle it. But what we really need, I don't know, this is my picture, but what we need is a common source of truth, right? But the common source of truth needs to be high quality. We talk about high quality data all the time, right? Software engineers need to give me good data. Data engineers need to fix my data because it's garbage. Well, you know what? It's all of our problems. It's not one person's problem. It's not a finger-pointing exercise, right? It needs to be governed. If the data is not secure, not governed, we're not cleaning it properly, we're not protecting user privacy, we got problems, right? You will have a shiny model at the end of the day, but then the government's going to go after you when you screw it up, especially in Europe. Scalable, open, that's big, right? We talked a lot about separation, compute, and storage. It seems to be a cool thing that Snowflake has did, but you know what? We've had it for years. It's great. It helps scalability, but also makes things a little bit different. All right. So when we look at the technologies that we have today, we can kind of bucket them into these two buckets. The first one is I call vertically integrated. And what does this mean? It kind of means that we have a standard stack or a set of a stack that basically allows us to do analytics and AI in a vertically integrated way. So the modern data stack kind of packaged that together for us in a shiny package that says that if you're a new team and you don't have data engineers, you don't have a lot of resources and time, you can just kind of buy this package, you buy these set of tools, and then everything is already integrated. Somebody already did all the heavy lifting to make it all work for you. So you can think of it as a vertically integrated solution. Now, if we look at Snowflake or even Redshift and BigQuery more and more these days, they're building a lot of these functionality into the platform already. So whether in the past you needed Fivetran to bring data in, now Snowflake is building all that functionality into the product, right? Redshift is building a lot of the functionality in. So you're going to need less and less of these external tools. They'll always be there, but you'll need less and less of them because the platform is vertically integrated. On the right side, this is custom. So this is where you come in and you can kind of plug and play. You can bring other vendors like Stream and Upsolver and Reverie and all these other tools, or you can bring open source solutions like Spark and Flink and DBT and things like that. So this is kind of build your own, do your own. But on the build your own stuff, a lot more complexity. You got to really understand what you're doing. You got to understand how each component scales, right? How much they all cost, how they cost over time at scale. Where on the left side, it's much easier. You can kind of pick it off the shelf and run with it. But there is vendor lock-in, and the cost does start to creep up as you scale, as we've seen a lot in the recent couple of years. But again, there's still duplicates, right? We still have a lot of duplication between them. The quality of data is still inconsistent because on the warehouse side, you have certain tools and capabilities to manage your quality of data, to control the quality. But on the other side, on the do-it-yourself, there's a slew of options and ways to do it that aren't necessarily consistent with the way that your warehouse is doing it. So you end up duplicating data. You end up having different quality controls across the board. And that makes life very difficult. And also the last one is reprocessing. I've seen this over and over and over again, where the same data is in two places, and you have to reprocess the same data twice, and you have to copy the logic and make sure the logic is synchronized. Okay, so we need something different, right? We don't need a repackaging. We don't need to take what we're already doing and give it a new name, right? We don't need to kill a new technology or start a new one. We need to think about things a little bit differently, right? So fundamentally, I think that there's a shift in kind of how we manage and collaborate and share high-quality data. And this fundamental change is driven by what I call shared storage. More openly, it's kind of, people refer to it as Lakehouses. Apache Iceberg is kind of the underlying technology of that. I'm not a big fan of the word Lakehouse. Again, it's like throwing another marketing label on top of shit that we don't really know what it is. Shared storage is about storing the data in a way that we can easily share it across systems and across clouds. And that's really the power here. So this is a bit of an eye chart. I'll give you a minute to kind of consume it. Again, this is more of like a decoupled Lakehouse architecture. So Lakehouse embodies many of those layers. So in the top, we have the authoring layer. This is where you write your SQL queries. This is where you write your data applications, whatever that may be, right? This can be Snowflake. This can be your own custom application. I don't really care. Right below it, you have this streaming engine. So there's a lot of conversations around whether it's streaming or batch or whatever it is. Personal opinion is that streaming is the future. Batch is just an edge case of streaming, right? So if you start thinking about it from a streaming engine perspective, now you can start consuming data from a lot of different places. Whether that source is some antiquated system that can only consume data once an hour or once a day, okay, it's a really slow stream. But if it's a data source that produces application events, thousands per second, you should be able to consume those because those will ultimately feed into your models and into your analytics. Below that, as you can see, I call table services. This is kind of where Upsolver plays a bit. This is a new component. I'll go into more details in a second. But this is a piece that traditionally has been inside of a warehouse where the warehouse is responsible for managing the tables for you. Where do I put the data? How do I sort the data? How many files do I have supporting that particular data set? Right? Are they big enough? Are they too small? Right? Where are they sitting? Is there retention? How do I deal with those things? So that piece have always been inside of a warehouse, and each one, or inside of a system, and each one was doing things a little bit differently. So if you had a retention policy that had to be defined or other governance policies, you have to duplicate them across systems, right? And somebody has to manage that duplication, that synchronization. So now we're sort of centralizing that through this Iceberg table format that makes life a lot easier. And there's additional services that run on top of that you can externally manage the retention. I don't need to do it in Snowflake or in Spark or in S3. I have another system that can actually manage that for me. And then you have the Iceberg layer. I'll talk about that in a bit. AWS kind of coined this zero ETL ingestion thing. Let's not talk about what the marketing of that looks like. But the gist is that there's a lot of sources that are common across the board. Whether it's Postgres or MySQL or Kafka or whatever it is, like a lot of vendors are kind of reinventing the wheel and bringing that stuff in. At the end of the day, we got to make it really, really easy for users to bring data in. We shouldn't have data engineers dealing with configuration and deployment of little connectors and stuff like that. So the notion of zero ETL is that you simply point to a source and you bring data in. And that's really the gist of it. So zero ETL ingestion, again, something that Upsolver does, but writing that data into an Iceberg table. Right? And then on the bottom, that's kind of where the shared storage is. So Iceberg, you'll see in a minute, is basically metadata and data. But it's all stored inside of Cloud Object Store. So whether I'm storing it in S3 or GCS or Azure Blob Store, it doesn't matter. It's consistent. Because we carry all the metadata with us within the table format, it's very easy for any other engine to just point to that table and know everything they need to know about it. They don't have to go to a catalog to ask, hey, what are the columns? Right? What are the policy definitions? How many files do I have? Everything is contained within that table, which makes it very, very powerful. And again, that's why it's a shared storage. So diving a little bit deeper into what shared storage is. So as I said before, you see a thin catalog layer at the top. In previous slides I had, that one was actually a very thick layer because the catalog was doing a lot of work. The catalog was responsible for managing the schemas, the partitions, the pointers to tables. You had to do work for access controls and things like that. In the model of this open format, that catalog becomes just a simple pointer. If Snowflake or Presto Trino or Spark needs access to the table, it says, hey, catalog, where is that table? Catalog says, it's over there in that bucket, go get it, right? This doesn't need to know anything about the schema, doesn't need to know anything about partition because it's not involved in the query planning. The second layer below that is the open table format, which is Apache Iceberg. There's other formats like Hoodie and Delta Lake, but this is kind of the one that's been catching on and really making a lot of vendors kind of committing to it. And again, I'll have another slide that goes into detail, but again, that's basically a metadata layer that represents the table. It knows how many files there are, it knows where they are, it knows what columns are existing, it knows everything there is to know about it, right? And that's a bunch of files sitting on top of object store. So whether that data is in S3 or in GCS, or is managed by Snowflake, or managed by Upsolver, or managed by Databricks, it doesn't matter. It's consistent. I know, like, if I need to know anything about that data, I can just go to that one spot and I can get it. I don't really care about who wrote it or who's reading from it. And then below that, we write the physical data into open file formats. Oops, sorry. Into open file formats like Apache Parquet, as support for ORC and Avro. But for the most part, this is just how you write your data into a columnar object file inside of an object store. It's standard. We've been doing this for years. Really not a lot of magic there. And then we write the data into the actual object store, into S3 or GCS. Now I'm kind of showing, the bronze, silver, and the gold layer. This is the medallion architecture. You can follow this. You don't have to follow this. There's no direct tie to shared storage, but this is a common model that kind of represents what you do potentially in a warehouse where you have some staging area for a lot of raw data, and then you do some business modeling and transformations, and that's your silver layer. And then your gold layer, you can think of it as your data model, right? That's kind of the final result that the business needs, right? But you're not duplicating data, it's consistent. So if you have Snowflake that wants to see data that's already been modeled, they can just query the silver layer. If I have, let's say, a notebook that I want to do some machine learning training on, I can just go into the raw bronze layer and I can grab it. I don't have to duplicate the data. I don't have to export it from one system before I import it into another system. So a lot less duplication. And the modeling is carried across. All right, so this is a picture. If you go to the Apache Iceberg website, you'll see this picture. You'll see it probably in a million blogs. It's just a way, it's just how it manages data and how things are connected together. So this layer is something that traditionally has been managed by systems, like data warehouses, Spark, and things like that. Now, this layer is completely decoupled in Iceberg. So we move it out of those systems, and we bring it into the Iceberg layer. So that means more systems can interact. And the main takeaway of this, and I'll go through some of the technical details, but the main takeaway for this is now you can have multiple systems writing and reading to the same table at the same time, right? Traditionally, if you were in the data warehouse, only the data warehouse can write into the table. Only the data warehouse can read from the table. In a data lake world, you only have one system writing into the table, and then you can have multiple systems reading from it. In the Lakehouse world, now you can have multiple writers and multiple readers on the same table, right? So if you have one system constantly loading new data into a table, then you have some engineer who is running some queries and updating the data in that table, they can run concurrently, right? And we can do this across the board. So if Upsolver is loading the table, but then somebody goes to Amazon Athena and does an update on that table, they can live together, right? We're not going to have any issues. So when you access that table, the first thing is the catalog says, hey, where is that table? You point to the table in S3, you grab this manifest file, the first metadata file, and it says, this is the current state of the table, right? And then we have this idea of snapshot isolation. Now, if we have one system, let's say Spark is updating that table, it takes the latest snapshot, the latest view of that table, and it starts updating, making changes to rows. Then a user comes in and they want to read that table. They take the latest snapshot as well, right? And they read that table. Now we have snapshot isolation. Spark is writing to one. The Trino or Athena is reading from the other. Now Spark is writing and is making changes. Now Spark is doing a bunch of stuff, right? They're writing data into S3. They're updating manifest files. They say, hey, I added 5 new files. They're sitting over there in this bucket. Here's some statistics about them. And then we can have maybe a third Spark agent starting to write data into the same table. They also take the snapshot, the latest snapshot, and they start making their own changes, right? They're changing the manifest files. They're writing files. Now, once they commit that change, once the first writer commits that change, it goes back and it checks, hey, I just committed the change. Did anybody else commit changes? Nobody else did. Fine. I'm going to change the manifest files, make it public, basically, and now everybody can see it. But the Athena that's reading the data, it doesn't know anything about the changes, right? That's the snapshot isolation. So Athena's still writing on the old snapshot, thinking it's the latest, Well, Spark already committed changes. Now, the next time Athena is going to run a query, they will see the most recent changes, right? So that's how we do this optimistic concurrency. Each one that's writing basically says, I think the world belongs to me. I'm going to do whatever I want. Whenever I'm done, I'm going to commit. If anything happens, I'm just going to fail, and then I'm going to retry my changes with the most recent snapshot. I know this can get difficult, kind of complicated, but, and then at the end of the day, we write durable files into S3 in Parquet format, and that's kind of the end of it, right? Now, because all of this stuff is done inside of a data warehouse, now we decoupled it from the warehouse and we put it in an object store inside of S3 or GCS or whatever. So now we can have multiple readers and writers accessing that table. And this is really, really powerful when you're trying to scale your workloads across many, many different use cases, whether it's analytics, security analysis, AI, ML, multiple different users, systems, AI, trying to access that data. This is the game changer, right? This is the fundamental shift that we're making, because otherwise I have to go to the warehouse and I got to do everything inside that warehouse. It's good for some vendors, but it's not really good for you as you start scaling. All right. So the other new piece that we kind of extracted out of the vertically integrated system is something that I call table services. In many blog posts and stuff like that you read about Lakehouses and Apache Iceberg, it's typically referred to as optimizations. People refer to it simply as compaction. So that's something that we kind of extracted out. And we said, this is a piece that now you can either use your current engine like Snowflake or Spark to manage, or you can have a separate system like Upsolver come in and manage it for you. And it does a lot of things. It does, small file compaction to improve performance and reduce storage cost. It does cleanup of those manifests. It helps in the case of GDPR and CCPA, where a lot of the deletes are typically soft deletes, right? But then somebody needs to hard delete them after some time, right? Or there's retention that you gotta exercise. So this system can actually manage it for you. So think of it as a lake manager that's responsible for managing everything inside the lake. As the lake grows and grows and grows and grows, you need some kind of central management system that is responsible and will give you visualization and reports and auditing on what's happening in your lake. So this is just a screenshot of an Upsolver feature that we released in early February. It's kind of hard to read, but on the top left there, we give you a storage saving estimation. So we actually look at all your Iceberg lake, all the tables, and we can tell you if you were to improve this, you can save X amount of gigabytes or terabytes, therefore translating into saving cost. On the right side, it's data scan optimization. So if you have a lot of small files, if your small files are not sorted, things like that, then your queries will just take longer to run. They'll be fine, they'll run, but they'll take longer. If we compact them and resort and reorganize the data, partition it and bucket it and things like that, we can improve the performance and reduce the scan time that a query engine needs to do. So just by simply looking at that data, we can give you a lot of estimations about how can we reduce your cost and improve your query performance. And we break it down by partition and across the table. And then you can simply click a button and say optimize, and then we go out and we optimize it. And this works on tables that we create, and it works on tables that somebody else created. Again, because we have multiple writer ability, we can manage it kind of alongside of other systems. And then the last piece of it is sort of the ubiquitous, I call it serving layer, ubiquitous serving layer or access layer. Right? We always talk about, Snowflake can do a million different things, Redshift can do a million different things, but that's great, but there's other cases where I don't need everything there. I want a notebook, or I want something else. I want direct access to data that's not in the warehouse. That ubiquitous serving layer is a concept where I want to bring my own engine to the party, right? But if my data is already modeled inside a Snowflake in a certain way, if I bring a notebook, let's say, or if I bring Python, I either have to use Snowflake's engine to query it, or I have to export the data out into my laptop or something like that to query it. But then I lose the data model. I lose a lot of stuff. I duplicate data, right? This way we have a central or more common, not central, but a common layer of data that's already modeled, already fully accessible, and I can really access it. And this is just a small sample of tools from any tools. So again, this is the unification aspect, whether it's analytics, embedded analytics, AI, whatever you want to do. Now we have a full sort of decoupled warehouse where it's modeled and prepared and clean and high quality data available for us in an object store that can be shared across clouds as well. So the last kind of takeaway slide from this, what does this all look like from the future? I kind of let you read it, but modern data stack, it's really not about anything modern, right? It's just status quo. Just go with the flow. Don't worry about terminology and marketing. This is just a packaging. It's a way for you to get started quickly. There are lots of tools out there, not just the one that you see mostly in advertisement, that can do this, and they can do a really good job, and actually a better job than what sort of the popular tools can do. And then the second one is new and expansion workloads on data warehouse, and this is also coming from the Snowflake earning announcement. A lot of the new and expanding workloads that are coming into warehouses will be stored on Iceberg. Redshift storing a lot of data on Iceberg already. BigQuery has started to store a lot of data, the customer data on Iceberg. Snowflake still in preview. Once it goes GA, sometime in the summer, I think, you're going to see more and more workloads on Iceberg. That's super, super powerful because it saves you cost and it gives you access to the data from a lot of different systems, and you don't have to overcommit and overpay to one vendor to get access to all your data. And then the last one, Lakehouse, is really shared storage. Right? When we talk about Lakehouse, don't fall for the marketing jazz. It's really about shared storage using something like Apache Iceberg. We put that layer there, and then we have access to high quality, modeled, easily accessible data without a lot of duplication, without a lot of friction. So that's pretty much it. If you take anything away from this whole talk, this should be it. All right, thank you.